So listen everyone, last class or last video we already completed block over block up to part 2. Okay, so we have seen that if a force is acting on the lower block, how will be the motion, together motion or separate motion, right? Now another problem we'll try to understand here. What is that? Now find the maximum applied force required to move the object together. So here one situation is given, two blocks are there, A and B. One friction is there between them. Here smooth surface. Here applied force. Here what is this one? Applied force, capital F. Now this force maximum value you find, so that both the objects will move together. Okay. So for that one, what we'll consider? First, if both the objects are moving together, they will have what? One common acceleration. So I'll consider both the objects are moving together. Answer, I'll write answer. Okay, let both the objects are moving together with a common acceleration SC. Okay, common acceleration they are moving. Okay, let me write A also, no worries. Let me write they are moving with a common acceleration A. The next, I'll do the free body diagram of first block, MA block. So what I'll do here? I'll do a free body diagram of MA block. Now next listen. Here applied force is capital F, and here in this direction one force will act, that is friction. Understand here, friction is between A and B, and on A object now friction will act in opposite direction of motion, because this A is trying to move, right? And friction will always oppose the relative motion. So friction will act on A block in such a that it will try to oppose the motion. So it will be like this. So friction is in this direction. Okay. So clear idea? Are you getting the point? No doubt here. Okay. Let me write also. So maximum friction is acting here. Fs max. Okay. Now next listen. Here it is moving with a common acceleration A. Clear. Now come to equation. How to write equation here? Already you know. If a right side force, one left side force is there, the net force acting is F minus Fs max, because the acceleration in this direction, no. So this force will be greater force. So greater force minus smaller force equal to mass times acceleration. So one equation what I can write here? Equation F minus Fs max equal to what? Equal to mass times acceleration. So this is one equation I'll keep. Equation 1. Now next listen. Let me draw free body diagram of B block, MB. Let me draw free body diagram of B block. Now here what I'll do? Now here B block is there. See on this B block, what force is acting? One is friction. Okay, normal reaction and gravity will be there, but that one we don't need to consider here. With vertical there is no motion, so horizontal force you say. Here also normal reaction will be there. Here normal reaction is this one. This is the normal reaction N, and downward is what? MAG. And if you want to find this friction also, you can tell what is this friction basically. This here normal reaction. This is the normal reaction N. Here it is MAG. Now here it is. Tell mu. This mu value given whatever. Mu into N you can write. Mu into what? N. And N value will be what? MAG. So that also you can write it. Mu MAG. For this block also you can do like this. For this block, B block, only one force. What is that force? Frictional force. So let's consider it is same force, that Fs max force. How much it is? It is mu times N, that N, remember? And this is nothing but it is mu times MAG. This is the force. And object is moving with acceleration A. Object is moving with what? Acceleration A. That means what you can understand here? This object, second block, is moving because of friction. Forward direction because of friction. Now, here friction is responsible for the motion. So I can write MB into A. Friction is responsible for the motion. Now, friction value is nothing but how much it is? Mu MA into G equal to MBA. Now here A if you want to write, what I'll write A tell? Mu MAG by what? MA. Or I can write this one little, MA by MB into mu G. Like this also I can write. Clear? So this is your acceleration I got. This is acceleration. Okay? Clear idea? Now I need F max. That means I need this force maximum value. Now what I'll do, this acceleration I'll substitute here. This acceleration I'll substitute here. And already Fs max value you know. That also I'll substitute there. Then I'll get a maximum value of the force. What is the maximum force can apply? Yes or no? On that object so that both the objects will move together. So after getting acceleration, what I'll do? Now this one I'll substitute there. Let me write equation 2. Equation 2 this. Now this equation 2 value I'll substitute on what? Equation, in equation 1 I'll substitute. All of you listen. We got common acceleration, right? Now what I'll do? This acceleration will substitute there. Acceleration will substitute there. What we can get, everyone check? F minus Fs max equal to MB into A, right? MB into A. Now what we'll do here, in place of A, we'll substitute that acceleration. So let's write substitute A, value of A in equation 1. So tell me what is A? MA? This is MA I think. MA. MA is there. Now here write what it is? MA by MB into mu G. So in the equation 1, you check equation 1 everyone. Here it is MA there, right? In this equation, this A value is substitute. So substitute A in equation 1, so this much is coming. Now Fs max also you know, you can write that. So now what is coming here, check first. Let's write here Fs max. Fs max equal to MA square by MB into mu G, right? Now this one you take that side. F equal to MA square by MB equal to what? Mu G plus Fs max. And what is Fs max value? What is Fs max value? Mu MAG, right? Now check here, mu G can get common, right? If mu G comes common, what you are getting? MA square by MB. Your mu G take common. MA square by MB plus what? MA. So this is what is coming, your maximum force. Maximum force. Yes or no? This is the maximum force required to move objects together. Okay? If a force is applied on the which block? Upper block. So what is this one? Now maximum force required to move two blocks together. Clear idea? Yes or no? So if two objects they have given and force is applied on the upper block, then what is the maximum force required to move blocks together? Now this much maximum force will be there. Clear? But listen carefully. If less than this, I will apply force. If applied force is less than F max, then what will happen? Less than F max or equal to F max? Then what will happen? Both the blocks will move together. Okay, blocks will move together. And if F will be greater than F max, F is greater than F max, then what will happen? Blocks will move separately. Yes or no? So this is your case 1, case 2. So in the next video, we will try to understand what is this case 1 and case 2 conditions. How will be the acceleration if they are moving together, and what will be friction between them, everything we will try to understand. Yes or no? These two cases we will understand in the next video. So first you understand this much today. Up to this you understand, if in this block you have applied force here, then what is the maximum force required to move the objects together? Now this much. F max equal to mu G into MA square by MB plus MA. Clear? Any doubt here? Any doubt? No doubt? So not in doubt. Thank you. Like and subscribe Vidya Lakshmi NEET Academy YouTube channel.